Hello and welcome to today's video. We're going to do an extension of the last video where we introduced counting. Now we're going to do some more practice with the principle of addition and the principle of the product principle. So these are also called the sum rule of counting and the product rule of counting. And these rules are pretty basic. So for a sum rule, it's if you have two separate tasks, task A can be done in ways, task B can be done in ways. You just add them up. So task A and B could be done in plus m ways. And for the product principle, basically the same thing, but now you're going to multiply the options you have. So if you have a list of choices and you want to know how many different ways could I do everything, it's just going to be the choices for the first option times the choices for the second option. So pretty intuitive rules here, but as you're going to see, the questions can get pretty difficult pretty quickly. So let's look at this one. How many ways can I customize a license plate that contains 2 odd numbers, 2 vowels, and then 3 numbers, assuming they have to be in this order? So we've got 7 numbers in all, so I'm going to write my little dashes here. So that's then I'm going to put the number of choices for each one. So 1, 2, 3, 4, 5, 6, 7. And now, okay, so now I've got 2 odd numbers. So odd numbers first, and then I have 2 vowels. So 2 vowels. And then I've got 3 numbers with no restriction. Okay. So how many different ways can I customize this? Well, I notice in my head, I notice that this is going to be a product principle one because I have a list of 7 numbers or 7 digits, I guess. I don't really know the term. And there's different things I can put there. I can put letters for some, and I can put numbers for some. Some I can only use odd numbers. So I'm going to have to multiply all the different options up. So how many odd numbers can I have? Well, 1, 3, 5, 7, and 9, right? Those are my choices there. So that's 5 options. And I have 5 options for the first one. I have 5 options for the second one. Okay, so how many vowels are there? So there's A, E, I, O, and U. We're going to assume Y is not a vowel for this. So we're going to assume there's 5 vowels as well. So 5 times 5. And then now 3 numbers. Well, how many numbers do I have? I have all the way from 0 to 9. Be careful to include the 0. Some people want to put 9, but it's actually 10 because I can have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's 10 different numbers. So 10 times 10 times 10. And now how would I write this? I wouldn't want to write it as 5 times 5 times 5 times 5 times 10 times 10 times 10. I would want to say 5 to the 4th times 10 to the 2nd. That's the number of ways I could customize, or 10 to the 3rd, my bad. That's the number of ways I could customize my license plate given these conditions right here. So the license plate is a really common question, so make sure you have this one down and you understand why it works this way. So I would recommend to draw out the little lines that represent each license plate digit, and then put on the top how many options you have, then multiply across, and that's your answer. So it's a common question. It's a good one to know. All right, number 2, assume there's 7 men and 8 women in a race. How many different ways could we choose first place and a male second place finisher? So this one's tough. I recommend you pause the video and really try this one on your own first. So let's think about what we're conditioning on. So we're saying, well, we want to know how many different ways. So that's going to be obviously the rules that we're using. Could we choose first place? So we can pick anyone for first place, but second place has to be a male. So let's think about it. We have 2 options. I have an option for first place, and I have an option for second place. How many options do I have? Well, for the first one, so if I choose first place and a male second place finisher, I'm actually going to think of this as, I'm going to start with the male second place finisher. How many male second place finishers can there be? Well, there's 7 men in the race, right? So there's going to be 7 options there that I can choose from. Then how many options do I have for first place? Well, I have 15 runners, and I know that a male finished second, so that leaves me with, so minus the second place finisher, minus the 1 person who finished second, so minus 1 second place finisher. So that means I have 14 runners left that have an option to get first place, right? Because the only thing I know that's happened is that a male finished second. So first place could be female or it could be another male, but there's only 14 options anymore because there's 8 women that are still available and there's 6 men that are available to finish first. So there's 14 options for first place and there's 7 options for second place. So that's one way to do it. That's the way that makes sense in my head. So I would get 14 times 7, and that's going to be 98 options. So there's 98 ways that you could have a first place finisher along with a male second place finisher. So basically there's 98 scenarios where a male finishes second. All right, so let's look at the next one. This last one's a little bit tougher, so definitely be ready for this one, and recommend, again, pausing it, trying it on your own before I do it. So first, I'm buying an ice cream cone and they have the following options. There's 3 different cone types, there's 8 different flavors, and there's 4 different sizes. How many ways can I make a cone if I don't mix flavors? So I'm only having one flavor, so that's pretty simple. If I only have one flavor, I can just do my standard product principle because I have 3 options, right? I have cone type, I have flavor, and then I have size. And I have 3 options for cone type, I have 8 options for flavor, and I have 4 options for size. I'm going to multiply those together, and I'm going to get, well, 3 times 8 is 24. 24 times 4 is, again, 96, I think, right? Yeah, wasn't that my exam? Oh, no, 98 was the last one. Okay, so close to the last one, but not quite the same. So number 1 is 96. There's 96 different ways that I could make a cone, assuming I don't mix flavors. So now for question 2. How many ways can I order a cone if I choose to mix 3 flavors? So note for question 2, we're assuming that the order doesn't matter. So a cone with strawberry at the top, chocolate in the middle, and vanilla at the bottom is different from, we're assuming that order does matter, my bad. So a cone with strawberry at the top, chocolate in the middle, vanilla at the bottom is different from one with vanilla at the top, chocolate in the middle, strawberry at the bottom. We're also assuming no flavor can be chosen twice. So once I've chosen strawberry, I can't go choose strawberry again. So it can't be on the first scoop and the second scoop. It needs to be 3 different scoops. So let's think about this. So what I'm going to do now is I'm going to draw my same lines that kind of give me my choices, but let's be careful here. The first one's going to represent cone type, and now there's going to be 3 lines for flavors, right? Because I'm mixing 3 flavors. So 1, 2, 3, and there's 1 for size. So these represent flavor types. So flavors, and then this is obviously cone, and this is obviously size. So start off with the easy ones. How many options do I have for size? I have 4. Then how many options do I have for my cone? I have 3 different options for cone type. But now the flavors. So there's not just 8 flavors for me to choose from, because now I can choose 3 different ones. So, well, let's think about each scoop. Assume I'm having 3 mixes. So assume that I can start with 8 choices, right? Because everything is available to me at first. I can choose any of the 8 flavors we have. But now be careful, because now it says that you can't assume no flavor can be chosen twice. So once I've chosen that first flavor, if I've chosen strawberry or chocolate, I can't choose that again. So that leaves me with 7 choices for my second flavor. And then what about my third flavor? I now have 6 choices for my third flavor. So now that's the way it goes, because now the reason I have 6 choices for the last one is because I've used 2 of the previous flavors and I can't use them again. So that's why that is the way it is. And notice that this would follow our second bullet point, our first bullet point, which says we're assuming order does matter. So a cone with strawberry at the top, chocolate middle, vanilla at the bottom is different. Well, that's because the first one I could have chosen chocolate, then it was vanilla, then strawberry. But another order that would satisfy this, it would be strawberry, vanilla, chocolate. So you could do the same thing, and that would count, and that is represented by this problem. And later on, we'll think about how we could make it to where you can't have a repeat, where they would be the same. But don't worry about that yet, so just try to get this for now. And now again, it's the product principle. We're just multiplying all of these to get our total number of options. So, well, what is this? It's 3 times 8 is 24. This is going to be a big number. Well, let's see how big it is. All right, so 24 times 7 times, I'm just going to do 6 times 4. That's an easy one, 24. So I'm going to get 24 squared times 7. 24 squared times 7. I know 24 squared. I don't want to risk it. I don't want to get it wrong here. Okay, let's just leave it as, well, we could leave it as 3 times 8 times 7 times 4. So 3 times 8 times 7 times 6 times 4. Just plug that into your calculator. That's the number of ways that you could do this. So let me know if you have any questions. Thanks for watching. Hopefully now you're kind of understanding that this counting thing does get tough. So just make sure you have these fundamentals down. If you need to redo the examples, it's probably a good idea. Because next we're going to be moving on to combinatorics, and that's when it gets really tough. So thanks for watching, and let me know if you have any questions. Have a good one.